Hello, and thank you very much for joining me for this talk about the Cognitive Management Plane. The Cognitive Management Plane is an initiative that Arista is spearheading, which I believe has the potential to fundamentally change the way networks are operated. And to give you the context for understanding what we want to achieve here, I think it's useful to take a step back and think about what our industry has achieved over the last, say, 40 years. The network, of course, is organized into three planes. There's the data plane, the control plane, and a management plane. My view is that the data plane has been a real success, that our industry has done a really good job of providing customers with the building blocks they need to create sophisticated, high-performance, multi-vendor, interoperating, federated, scalable data planes with rich services deployed end-to-end. I'm talking here about data plane technologies like IP forwarding, Ethernet bridging, MPLS label swapping, GRE tunnels, VXLAN, IPsec, MACsec, a small set of building blocks that gives our customers tremendous capabilities. On the control plane, I actually feel that the industry has done a very good job here as well. There are well-standardized protocols exchanging reachability information, network control information, across domains, across geographies. It works multi-vendor. It all federates cleanly. It scales really well and enables our customers to build and operate feature-rich networks providing advanced services. And here I'm talking about control plane features like, well, BGP, OSPF, BFD, LACP, a small handful of protocols that our customers can use to assemble networks that run really, really well. Now let's turn our attention to the management plane. What happened? It's like the industry forgot. Instead of giving you building blocks to build a management plane, what have we delivered? There's a command line interface designed for human operators to go device by device by device, entering commands. How well is that going to work when you've got tens of thousands of devices? We've given you SNMP. SNMP allows some piece of external software to pull out certain statistics, certain operating parameters at a very modest pace. It leaves it as an exercise to you what you're actually going to do with that information. Plus, it's such a small subset of the relevant information in your network, it's hard to even get started doing anything useful. If you look at recent developments on the management plane, we've got OpenConfig. And OpenConfig is an important improvement for sure, no doubt about it. Streaming telemetry is much better than polling. Being able to control the whole configuration is also a great advance. But it's still not actually a management plane. It's still just a hook. It's just a way for a very sophisticated operator to get control of their devices, to build their own management plane. And in fact, that's what most first-tier operators do. They invest tens of millions of dollars in custom software engineering to create their own management plane using this small set of hooks that vendors provide in their switches. This is simply out of reach of most customers. And we can do so much better. And that's what the cognitive management plane is trying to do. It's trying to give you the building blocks you need to create a management plane that works as well as your control plane and data plane work today. A management plane that's multi-vendor, that interoperates, that scales. It federates across administrative boundaries. It supports your network the same way the control plane and data plane do. And think about the capabilities that a sophisticated management plane can bring in terms of the automatic provisioning and configuration of new devices, network-wide image management to get the right software onto the right device, compliance monitoring to make sure that every device has the right configuration, is running the right software, that we don't know of any security issues. Think about the power of having all the telemetry streaming out of your boxes into the management plane where it can be analyzed, presented to you historically, where we can apply machine learning algorithms to give you adaptive alerts that respond to changes in the condition of your network, that we can give you capacity forecasts that look at when you're likely to hit capacity bottlenecks, that we can do outage root cause analysis. If there's an anomaly or a bad event in your network, to go back and look at the data and figure out what went wrong. These things all become possible with the cognitive management plane. So now let's take a look at how the cognitive management plane is actually built, how it actually works inside. The key idea here is to organize your network into units that are managed as a unit. Probably a unit within a certain geography, maybe a certain class of device, maybe within a certain administrative boundary in your organization, maybe all devices of a certain vendor. So you take a subset of your devices, the blue devices in the figure, and you set up for them a cluster. Then for each device in the cluster, you configure the device to stream its state up into a clump of compute and storage. This is running ordinary servers, ordinary server hardware, running software that can receive all of this state, store it centrally across all of time. You wind up with a complete record of every state of every device in your network. And I'm talking about data plane state, like counters, laser temperatures, power supply voltages. I'm talking about control plane state, all of the routes, all of the ARP entries, all of the MAC address table entries, all stored, every state change stored over all of time in a scalable, in the cloud database. And then on top of that, we run stream processing. And the stream processing analyzes the state. It cleans the state up. It performs aggregations, statistical summarizations. It converts the state from some device-specific model into a well-standardized model. It performs analysis on the state, such as trying to understand if a link went down in the network, what are possible causes, what are related events. The stream processing layer can make those kinds of inferences. And then on top of the stream processing, we run applications that give you the direct visibility, give human operators the direct visibility into the state and the ability to set policy and then enforce those policies across the configurations of all of the devices that fall under that management cluster. And the way that this scales is by having more than one management cluster. You do this for many reasons. You do this for simple survivability. If there's a problem in one part of your network, you don't want that to affect the other parts of your network. You also do it because there are separate administrative domains of control within your organization. Or perhaps you want to peer, essentially, with another organization so that you can share some management information. Or it may be that each vendor provides their own management cluster and you want a combined view of the networks of your blue vendor and your green vendor. For all of those reasons, the cognitive management plane supports peering, where state is shared between the clusters, much like the way in routing you can share state with BGP, controlling filters and policies to specify what state gets shared and what you do with the state that you import. The same thing applies here. You configure policies about what state you want to export from one cluster into the other and what you want to do with the imported state. So for example, suppose that the green vendor provides a really great segmentation application. It's an application that takes a high-level policy statement of what devices or customers are allowed to talk to which other ones, and then generates access lists or PBR rules or VLAN configuration or whatever is required to enforce, to implement that policy. That works great for the green devices. How do you get the blue devices involved too? Well, by using cognitive management plane state export, the management cluster on the left can stream its state into the right topology state. Which devices are available? How are they connected? Then the application on the right runs, applies the policy rules to those devices, generating access lists or PBR rules or whatever the correct mechanism is in a standard format, such as OpenConfig, streams that back across to the blue cluster, which then loads that configuration into the blue devices, giving you a true single pane of glass management view of your whole network while taking advantage of the unique capabilities and functionality of different vendors. We believe this architecture will deliver an unprecedented level of scale and functionality in the management plane, giving you the building blocks you need to create a management plane with the level of sophistication and operational flexibility that you're used to in the control plane and data plane. Here's an example of the kind of application that we've actually already built on the cognitive management plane. Adaptive alerts are a simple machine learning mechanism that watch your network, figure out what's a normal operating parameter, and then alert you when the actual behavior of the network moves outside of that normal range. And this can give you a an early heads up to a problem in your network. In this example use of the application, we receive an alert when the traffic level changes suddenly on one member of a link aggregation group. Now, the total amount of traffic on a link aggregation group is as expected, but the cognitive alerting system recognized the fact that that one member was kind of unusually lightly loaded. And then by drilling down into that alert, we can see the root cause, which is that there's a load balancing problem across the links in the aggregation group. Here's another example of the power that you get by pulling all of the state of your network into one place. In the topology viewer, we can see an entire enterprise network. We see the data centers, we see the hybrid cloud deployment, and we see the campus deployment. And using the overlay feature, we can overlay network operating parameters onto this topology view. This enables the operator to quickly figure out how observed behavior in the network corresponds to the way the devices are connected, pinpointing CRC errors or congestion or other operational issues on the exact links or devices in the network that are responsible for those problems. I hope this gives you some idea of the potential of the cognitive management plane, and I hope that you're as excited about that potential as I am. Thank you very much for your attention.